Welcome to 01 Nexus, where we simplify technology and bring the future to your fingertips. From the latest innovations, AI breakthroughs, and digital trends, to how everyday tech actually works, we've got you covered. Whether you're a tech enthusiast or just tech curious, you're in the right place. Ever wondered how these flying machines, called drones, stay in the air, follow you around, and even deliver packages? In this video, we're breaking down exactly how drones work, from flight mechanics to navigation systems. Let's dive into the fascinating tech behind drones. A drone, or UAV, short for unmanned aerial vehicle, is an aircraft that operates without a human pilot on board. It's controlled either remotely by a human or autonomously using software and onboard sensors. Drones come in all shapes and sizes, from hobbyist quadcopters to military surveillance UAVs. Let's break down the main components of a standard drone, especially the popular quadcopter design. One frame, the body that holds everything together. Usually made of lightweight materials like carbon fiber or plastic. Two propellers and motors. Most drones have 4 propellers powered by brushless motors. These control lift direction and stability. 3 battery, typically lithium polymer (LiPo) batteries that provide the power. 4 electronic speed controllers (ESCs). These connect the flight controller to the motors. 5 flight controller, the drone's brain. It processes all flight data and sends commands to the motors. 6 GPS module, used for position tracking navigation and autonomous flight. 7 sensors, includes gyroscopes, accelerometers, barometers, and sometimes ultrasonic or LiDAR sensors for altitude and obstacle detection. 8 camera, for photography, video, or even FPV, first-person view flying. Drones fly using the principle of aerodynamic lift and motor control. Let's break it down. Each of the 4 motors spins a propeller by spinning in opposite directions, clockwise and counterclockwise. They balance torque and keep the drone stable. When all propellers spin at the same speed, the drone lifts straight up. To move forward, the rear motors spin faster, tilting the drone forward. To turn or yaw, one diagonal pair spins faster than the other. Flight is controlled by adjusting the speed of individual motors. The flight controller constantly measures balance and orientation using gyroscopes and accelerometers, making rapid adjustments to keep it stable. Drones are usually controlled by a remote controller or through a smartphone app, often using radio signals like Wi-Fi, Bluetooth, or RF transmission. Remote control inputs. Throttle controls altitude up-down. Yaw rotates the drone left-right. Pitch tilts the drone forward-backward. Roll tilts left-right. Advanced drones can also follow GPS waypoints, return to home (RTH) automatically, use vision-based navigation for indoor flying without GPS. FPV drones. First-person view (FPV). Drones transmit live video from an onboard camera to goggles or a screen, giving pilots a real-time view as if they're inside the drone. Modern drones are smart. They use obstacle avoidance systems to fly safely, even in tight spaces. Common sensors include ultrasonic sensors for altitude, infrared sensors for object detection, visual sensors for optical flow, LiDAR for 3D mapping and terrain following. These help drones detect objects, avoid collisions, and even track moving targets. Drones aren't just for fun, they're changing industries. Aerial photography and filmmaking. Agriculture, crop monitoring, spraying, soil analysis. Delivery services, fast delivery in remote areas. Search and rescue, reaching disaster zones quickly. Construction and surveying. Military and surveillance operations. And that's how drones work. From powerful motors to advanced sensors and smart controllers, drones are a perfect blend of aerodynamics engineering and AI. If you enjoyed this breakdown, give it a thumbs up and subscribe for more simplified tech. Until next time, thanks for watching.